is Anaton Benzel. Welcome back to my channel. We are going on this LeetCode problem set, and we are reading through and doing question number 76, minimum window substring. Now, I've spent the last 3 minutes reviewing this problem, and we are going to go through it together again, maybe once or twice. So, let us jump into the minimum window substring. And again, the solution is in Python. So given two strings s and t of length m and n respectively, return the minimum window of substring s such that in every character in t, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. And these are the test cases, or the examples, which are also subsequently test cases in the console. So the entire string is the minimum window for number 2, which makes sense. For the input of S, we have all of these letters, and T, A, B, C. The output is B, A, N, C. The minimum window substring for B, A, N, C includes A, B, and C from the string T. So this is hard. I don't know where to start. Oh man. Jeez Louise. Also, I haven't submitted anything for this yet. I just want to show everyone. Yeah, given two strings s and t of the length m and n, return the minimum window substring. So just this alone is making me think we should do a 2-pointer sliding window approach. And the only reason I'm saying that is because every character, including the duplicates, should be included in this window. But if we had A, B, A, and C like this, we had the minimum window, which we could increment a left pointer over for that. And I think that would work. So we would need the 2 pointers, left and right. I wonder, could I use import the counter? There's nothing that says you can't in here. So I could say, from collections, import counter, because that could be what counts these things, including the duplicate. So in that counter, yeah, let's start there. If they don't let me do that, that's fine. But from collections, what did I say? Import counter. And then I'm thinking for this, we should start with a base case. So if it isn't S or T, then we just return that empty string. I feel like that would be the next step here. So if not S or not T, return that. So I think that would be each test kit will be generated such that the answer is unique. So I think here we're gonna need 2 main counters. I think we need something like, let's say, target counts and current counts. So for the target counts, that'll be for the characters in the string t, and then the current counts would be for the characters in the current window. But we need something to keep track of those characters. Right? I could say required characters, which is the variable that keeps track of those characters in T that are not yet matched in that current window. So that's the length of the target counts. And this would be just the counter in general. So we need to be able to move the left pointer, but the left has to be in the farmost spot. So we're going to say the left is 0 and the minimum length is float infinity, and the result is open. Return the minimum number in every character. So we need to move the right pointer to expand that window, and the left pointer to then subsequently shrink that window. So, but we need to do that while maintaining that required character count. So, okay, wait a minute. So open up the right pointer, because then once that required characters hits 0, that means we've found a valid string. So I could say like for right in range, and then add that, have that for loop have a nested while loop that then says required characters, if they're equal to 0, then the left is less than or equal to right. So let's play with that idea. I like that idea. I think that has some sustenance to it. That what's it called? That could work. So we're gonna do some nested loops. So for right in range, which would be the length of S. If S right in target counts, that means the current current counts get incremented. So current counts of S right are incremented. But if current counts S right are equal to the target counts of S right, then we need the required characters to decrement by 1. Right? I think. So then while required, okay, so while required characters are equal to 0 and left, this is what I was saying before, right Then if right minus left is 1, which is less than the min length, then the min length is equal to right minus left plus 1, which means the result is then s left right plus 1. So it becomes 0. So required characters become 0 means we found that window and all of those characters from T. And then we have to update that result. So if s left in target counts, current counts of s left are decremented, right? Yeah, if current counts, so if they're left, it's decremented. I feel like, so current counts of s left are less than the target counts of s left, then the required these are required characters, so I should fix wherever I've done that. Required characters. Increment. That means the left. And then we just return result. So that would update that accordingly. Okay. So let's read through this one more time and see. Target counts, counter the length of, okay, hold on. Let's reread through the question. So given two strings s and t of lengths m and n respectively, return the minimum window substring of s, such that in every character in t, including duplicates, in the window, if there is no such substring, you return the empty substring. Correct. Okay. Test cases will be generated, blah, 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 blah. Could you find an algorithm that runs in O m plus n time? This should, in theory, go in O m plus n time because we traverse the string s once in this. And then we have the additional processing for each character is constant time. So that should work. But that feels like a famous last words thing for a developer. That should work. That's fine. That's all right. So we have our target counts, our character. Our target counts and our current counts are the main counters. And I feel pretty good here because this just needs to account for those characters in T. Yeah. Okay. I've also spent about 20 minutes on this so far, which is pretty fast for a hard. So that doesn't give me a vote of confidence that I did it correctly. Let's run it. I say skeptical work is not defined. Where are we? Where is that? Oh. With a D. I was like, why is that wrong? This makes me nervous. So running it gets accepted. Runtime 34 milliseconds. So that makes me feel like I am not considering something. Let's just go ahead and submit this. Well, okay, hold on. Before I submit it, because I am second guessing myself just because I got it. Like, I've had this issue before where it's my test cases say, hey, this is right, and then I missed an edge case and it fails when I try to submit it. So walking through this one more time. Also, it might say I'm not allowed to do that, but it didn't say that on the test on this console log. So I'm hoping that I'm still able to use this. This is my kind of saving grace right now. Okay, so we have our base case here. We have these. So the current count is for each characters in the current window, and that is going to change based on all of this. So I'm just going to submit it. It's already making me nervous, though. Okay, got accepted, but like barely. But barely. Oh, man. Under 22% on both runtime and memory. Oof. That one hit me right in my honey nut Filios. Dang, man. Anyway, I mean, for 20 minutes, that wasn't terrible, though. Like, that could have been way worse. And I'm glad that it was just a sliding window algorithm that I could use. But also, there are definitely better solutions out there. So I'm going to have to revisit this problem at a later date. But overall, I'm not terribly unimpressed, considering that was in 20 minutes. But and my last hard problem that I did took me like 6.5 hours. So you win some, you lose some. And I didn't do that great on this problem, but it did get accepted first time around, which means from here I have a perfect jumping off point to try to optimize this even more, even farther, even better. So that's kind of nice, you know, because it's not every day you get to do a hard problem that gets accepted right away. Anyway, so I will leave this code in my GitHub repo, which is linked down in the video description down below. You guys, please fork and clone it. Make it better. Make it better. You cannot make it worse. I'm telling you, you cannot make it worse. Have some fun. Learn something new. And thank you guys so much for watching. I will see you in the next video. Goodbye.